little bit dark because we're out of power. The hotel lost power. Here we are, the lights are back on.
This proposal, and can you cost share on it? Okay, and then he comes back the next day with another proposal that he needs cost share on, and the next day with another proposal. He's still going strong, so we're very lucky to have him, and he's been wonderful with Ph.D. students and master students. I think 30 master students and 15 Ph.D. students, is that correct?
Something like 12, I think.
12, something, and more postdocs than you can imagine. Have gone through his program, and many have had outstanding careers and continue to be national leaders. You know, we have, and I'm very grateful for it, a lot of hotshot young scientists in our department, young faculty, and everyone should know that before they were the hotshot on campus, Mohinder was the hotshot on campus. He was the young guy who brought in the big research program and was the Sloan Fellow and is the Fellow of the American Physical Society. And he did all that with teaching 2 classes a semester, with no electrical power except he had to share with Art, you know, who turned on which magnet when. And, you know, he built the research focus of the department. I mean, without Mohinder, we would not have a research-intensive physics department. I don't think there's any doubt about his coming precipitated a lot of what we're very grateful to have in the department. And he's been a role model for me as I've migrated into administrative roles, to see him continue to be a great teacher. I remember when I came here, he was not feeling like he could teach full-time and or teach standing up. And so instead of taking the time off, he just taught sitting down. And I remember him teaching like that for a year. He would sit there and work from a chair because he was still going to teach. He was not going to give up and change what he wanted to do on a daily basis. And many of my students remark how great his classes were and how much they enjoyed his teaching. So, and the other comment I'd make about Mohinder is, if you know him, you'll probably chuckle at this, you know, he's not the R word, but he still comes and tells me what to do sometimes, but he does it in the Mohinder way, right? He comes to my office and says hello, and we chat for a bit. And then he tells me what's on his mind, and maybe, you know, what he would do in a certain hypothetical situation. And then we chat for a while longer and catch up, and then he kind of, you know, wanders out of my office without asking me exactly what I'm going to do or what decision I'm going to make. But when I come to make that decision, I know exactly what Mohinder would do in that decision. And his advice is always great advice. I mean, he's seen a lot of chairs come and go. And he's seen a lot of university administrators come and go, and he's been very focused on his research and to have it of the highest quality. When I go to other departments around the country, and it still happens, they don't ask me how anyone is doing in the department. They say, "How's Mohindar Seehra doing?" Because everyone knows him in condensed matter physics, and that's what I hear when I go to places and I talk to some condensed matter folks. They say, "How's Mohinder doing? WVU? What's he working on lately?" And so he's still very, very well known, very respected. And tonight I've asked Jerry Huffman, class of 1962 and 65, who's at Kentucky, to come share a few words about Mohinder and his career. So, back here in this corner.
5 universities, all of whom are interested in energy research, particularly fossil energy research, and it's called the Consortium for Fossil Fuel Science. Those universities include Kentucky, of course, West Virginia, also Auburn, Utah, and Auburn. I mentioned one twice. Pitt. Well, they're Pitt, yeah, sorry. Miss Pitt. Well, nobody's here from Pitt anyway. So. Now, we've been working on this program for over 20 years, and Mohinder has been a member of the consortium for almost that whole time. And in that time, I would estimate we probably had at least 50 professors who participated in this program. But let me honestly say that I believe that Mohinder has been the most productive of any of them. Let me tell you why I think that. Mohinder is interested in everything that is a physical problem, and he collaborates with everyone. We have meetings, and he listens, and this is interesting, and he will, afterwards go up to the person and say, look, what you're doing, I think I can help you. And he tells him what I'm going to do. Now, he has about 50 different techniques that he can use within his laboratory. I'm glad he's got 2 laboratories now. He really needs it. And so he does it. And he has collaborated with virtually everybody that has ever been in our program, particularly with me. So I'm very grateful for that. And another thing I want to mention is that I really believe Mohinder has a different way of looking at problems than almost anybody I know, because he finds everything interesting. And in every problem, and we deal with problems dealing with fuels, so we deal with a lot of catalysis problems and problems that most people don't deal with, like hydrogen production and hydrogen storage. And one of the ones that I really like is elastomers. Elastomers that go into engines and how well they seal so that the fuel doesn't leak out of the engine. And a lot of people would look at this problem and they'd say, well, that's not really a physics problem, that's a chemistry problem, or that's an engineering problem, or that's a problem for a polymer scientist. But Mohinder doesn't do that. He looks at these problems and he comes up with something completely new that is physics. Now, a good example is hydrogen production. We did a lot of work on hydrogen production back during the Bush administration, and in fact, we're still doing some work on it. And Mohinder looked at that problem and decided he wanted to do something on hydrogen production. So what did he do? I think he said to himself, I'm just saying this, well, what's the oldest method of hydrogen production? Electrolysis. What can I do about electrolysis? He came up with 2 ideas that were just brilliant. One of them, he added a little bit of activated carbon to the electrolyte. And that produces basically an electrolytic carbon gasification and reforming process, which makes hydrogen. And the bottom line was the voltage to do it was lowered by a factor of 5, and the amount of hydrogen produced with the carbon in there is increased by a factor of more than 2 versus just a normal electrolyte. And that was pretty good. But this also produces carbon dioxide, this particular method. And as you all know, carbon dioxide is going to kill us all, right? You hear that on the radio every day, right? I talked to somebody about that earlier. He's giving me a dirty look right now. But it is a serious problem, and if you're going to do research in fossil energy, you've got to do something about it. So he came up with another method. He added a little bit of iron sulfate to make iron an electrolyte for the a catalyst for the electrolysis process. And that worked just as well. So he's got 2 methods out there that are both great for improving electrolysis by a factor of about 4 or 5. That's typical. He also, in the area of catalysis, comes up with a lot of interesting ideas. For example, he comes up with great ideas for measuring the sizes of nanocatalysts. And he can do it with X-ray diffraction. He does it very well by, measuring the half-widths of peaks. He can measure the average size of these nanoparticle catalysts to within 1/10 of a nanometer, very accurately. And he does it, you can do it by transmission electron microscopy too, but you're not going to investigate more than 100 particles with that technique, whereas he is looking at the whole sample. Another way he likes to do it is with magnetic measurements. He does it with magnetization. He measures the magnetization versus the field. Raspberry-Rand functions, it turns out that they have a factor in there that is related to the size, and again, he can measure the sizes of catalysts to 1/10 of a nanometer. So these are all just interesting things that are much different than anything anybody else does. I think my favorite is our problem that we've been working on with the Army. We have a military fuels research program, and one of the things they're worried about is the fact that if they go to Fischer-Tropsch fuels, the Fischer-Tropsch fuels do not react with the O-rings and the gaskets in the engines to make them swell. And ordinary fuels have aromatics in them that do react, and they make them swell up, and therefore they seal. So this is a big problem. How do you make Fischer-Tropsch fuels swell? So again, in his typical way, he takes a different way of looking at this problem. A lot of people would say, that's not a problem for me. But he digs into the literature and learns about something called Hansen's solubility parameters and figures out that there are three interatomic forces, a polarization force, a hydrogen bonding force, and another attractive force, an atomic force, and starts to figure out how those affect the way these swelling molecules, swelling fluids, go into the elastomer, bond with it, and cause it to swell. And he produced some beautiful results on that. And basically, it is a physics problem to him. And the way he does it, it is actually a physics problem, and he's produced some beautiful solutions to it. So those are just a few examples. And, you know, I think, you know, for young people here, this is a good way to think. If you're a physicist, you should think any physical problem out there has some physics in it. And if I think about it hard enough, I can figure out what the physics is in that problem. Just one final thing. That is that having worked with Mohinder for all these years, as many other people in our consortium have, I really believe he's one of the most generous people around, because if you contribute anything to one of his papers, no matter how small it is, you will be a co-author on that paper. My resume is a lot fatter because of Mohinder. So, just want to congratulate you, Mohinder, and I think we should all give him a big hand in embarrassment.
And the trick in those days was, if they landed in your backyard, they had to give you a bottle of champagne. Well, 10 feet more it would have been in my backyard that he got the champagne. Well, what he did shortly after that was he went to this beautiful tree in his backyard and he cut it down. I mean, it was what you call a trimming job. It was a very aggressive trimming job. There was nothing left. And I thought he was trying to, well, get rid of the tree. But the next year it came out beautifully, and I think it's been beautiful ever since. So if you ever get some concerns about gardening, go to Mohinder. I think he could give you some good advice. I'd like to also offer a couple comments about Mohinder and his career as a researcher. And Dean Jones, I'd want to tell you that unfortunately, not unfortunately, fortunately, Mohinder is not unique in his department. I've had the opportunity to work with people like Art Pavlovic, who I know is here, Barry Cooper, James Lewis, and I know that they work with other people. You've heard Jerry Huffman describe the way he works with other people. He's not unique. Pavlovic and Mohinder and Mohinder's family and my family came to Morgantown in 1969. We were in the same class.
All these nice things. Liquidura, thank you, all your support, trainer, all your support. And of course, all the chairs I've worked with. Pavlovic, Dr. Pavlovic, who hired me, very supportive all the years. After that, Bill Veza, I think I miss him a lot, frankly. He was just wonderful, very supportive, and I think he did a lot for the department. And Dr. Pavlovic came back again, second time as chair. And so he has been, you know, his support has been very valuable. Marty was acting for chair for a while. And then we hired Larry Halliburton. I mean, he was very supportive. So I've been very, very fortunate that I had some wonderful chairs to work with. And Al has been also, you know, it's just wonderful. We are so lucky to have Al. This morning I told the story how we got to hire him. you have to be lucky sometimes to get the right person. We had tried to hire somebody else. He turned us down. Then we had turned to Earl, and what he has built is just unbelievable. And the work he has done with this building, I don't think the amount of time he has put in is just unbelievable. And on a personal side, I think whatever I have achieved, I could not have done without somebody who doesn't know any physics. That's my wife. I'd like to stand up, and please stand up. She has been a pillar of strength for me. I had some health issues over the years, off and on, and she was just there for me. Without her, I probably wouldn't have pulled through some of those, difficult times. My children are here, very lucky to have both of them here. My grandkids are here. Uncle Goel, my elder daughter's husband, is here. So very fortunate to have them here. And some of my grad students and postdocs are here. I see Manjula, Kanan is there, a couple of other Steve I met. And so they are all the people, I learned more physics, also a lot of physics from them as I try to teach them. So it's been really, really wonderful. Sport I have gotten through from the Energy Research Center over the years, combined with other sport I get from other places. I think that allowed me to hire postdocs. And so we brought a lot of very good people, many from India, many from here, and trained them, and I think they are doing very well. So it's very, very satisfying to see them succeed. And so I'm just very grateful for this evening, and I think all the comments that you have said. And so thank you all. I hope to continue to do some more work for a few more years. Thank you.
I almost forgot something, and I'd be very embarrassed if I had. A couple of your former students sent me a note that I needed to read. So Prasanta Dutta and Susmita Paul, who live back in actually my hometown of Tampa, emailed me a note last night that they insisted I read tonight in your honor. So let me go through it here. WVU Physics has always been a nice place to work. During our stay there, we felt the entire department is like a very sweet family. Folks, please keep it up. However, this letter is about the respected Professor Seehra, who is a savant who has dedicated himself to the service of science and who has opened a new horizon for his hundreds of students and research fellows. Any farewell ceremony is a matter of sadness, but Professor Seehra lives always in the memory of his research fellows, colleagues, and associates. They know you're not retiring, right? Okay. He is a great man of pleasant personality, exceptional capability to teach and to train students. He was always easily accessible to students, fellows, and colleagues. Dr. Seehra has left a lasting impression upon all who have come in contact with him. We consider ourselves very fortunate to working several years with Dr. Seehra as research fellows. Regarding his outstanding research accomplishments, it is well recognized that he is among the top experimental researchers in terms of quantity and quality of his research publications. Professor Seehra's professional career has been dedicated to honest scientific advancement. We believe he has profoundly influenced the new generation of young scientists. Finally, we wish you, Professor Seehra, sound health and your tireless persuasion of research. That's actually what's written, but I think they mean pursuit of research in the different branches of science, ranging from the materials science to physics, hydrogen fuel, coal chemistry, etc. Dr. Seehra, you are the smartest scientist we have ever worked with. You are better than best. With warm regards, Prasanta Dutta and Susmita Paul. And now Dean Jones has a few remarks, special bit of ceremony.
Thank you, Earl. It's been marvelous to hear these testimonials about Marty and Mohinder. But I'm not surprised, because in the past year, each of them took a special interest and made it a point to come and visit with me. And I distinctly remember both visits. Marty came in, he's quite concerned about the future of undergraduate student advising. And he had some really interesting perspectives. I could tell right away he's the person undergraduates really, really look up to. And Marty, you had a big impact on me, and I see that as a very, very important issue. And so your thoughts and suggestions are going to make a difference. And Mohinder came and talked to me about research and the fact that faculty can have different roles and be happy with them, and he explained his situation. He was so enthusiastic about his research. But you know, I'm kind of disappointed that you haven't hit me up for cost sharing yet.
I get to talk to Fred King, so you
Oh,
are
okay.
isolated.
Well, yeah, I have Fred King running interference for me.
Yes, yes.
Okay, well, before we close this special evening, I'd like to take a moment to thank in person Dr. Seehra. Mohinder, you may be a little surprised by this, but would you please come join me at the podium?
So I'm going to ask my wife to join me.
Sure, please. It's my pleasure to announce a special surprise that Mohinder has been working on. We all know that Dr. Seehra has a special interest and love for research. But because he knows the power of how research can transform lives, he's established the Dr. Mohinder S. Seehra Research Award. And this award will provide funds annually to recognize excellence in research conducted by physics Ph.D. students. So we're grateful to both of you for your long service and your many contributions to the university. And this generous gift is going to strengthen a program that we all know is already excellent. It's going to allow the department to attract the very best PhD students. So thank you both very much for your contribution.